Hello everyone, I am going to discuss the topic of ion exchange chromatography today. See, this technique is used in molecular biology. Ion exchange chromatography is used for the purpose of separating different ionic species. What are ionic species? Ionic species, what is an ionic component or ionic species? Is the species which has charge. The charge can be positive charge and it can be negative charge, right? The charge can be positive or it can be negative. A negatively charged species is known as anion and a positively charged species is always known as a cation, right? For separation of cations through ion exchange chromatography, the technique is known as cation exchange chromatography. And for separation of anions through ion exchange chromatography, it is known as anion exchange chromatography. Right? Now, this is the basic concept of ion exchange chromatography. Now, exactly what are the examples? What are the examples of these ionic species? See, amino acids, they carry charge among them. There are 20 amino acids which make up all the proteins and all proteins are charged. How? See, this is the general structure of any amino acid. It has a NH3 on one end and CH3 and NH3 on the other ends. Right? Now each and every amino acid and each and every protein is made up of hundreds of amino acids. And due to these hundreds of amino acids, every protein has a particular charge on itself, right? The charge can be positive again and this charge can be negative. But there is a particular point on an amino acid, on a protein. This is a protein. It's a protein. If I say, if I talk about this, so there may be amino acid 1 over here, amino acid 2, amino acid 3, in this way it should be there. And here also this one is amino acid 4 and then amino acid 5, 6 and many amino acids, so on and so forth, are making this protein. Right? Now due to these many amino acids, this protein is going to have a charge. The charge can be positive or negative, but there will be a point, there is a particular pH at which the net charge will be 0. Net charge will be 0. And this pH is known as Pi, isoelectric point. This P is known as isoelectric point or Pi. Right? For separation of any cation or anion, any cationic or anionic protein through ion exchange chromatography, you need to know this isoelectric point. If you know the isoelectric point of a particular protein, you will be able to separate this protein. Right? Now, what is the process of ion exchange chromatography? How do we separate these ionic species? See, I said that there are two types of ion exchange chromatography. One is cation exchange chromatography and second one is anion exchange chromatography. And anion exchange chromatography separates anions and cation exchange chromatography separates cations. So I will start with this one, the anion exchange chromatography. Right? Let us take question number 1. I will take the example of there is a mixture of proteins and protein A, B, C, D, E. Right? Among these, this C protein is pepsin in this mixture, and we have to separate this C protein from the rest of the proteins A, B, C, D and E. How you will separate? See, first of all, from the internet, you will find out the Pi of this protein. The Pi of pepsin is 1. Pi is the isoelectric point. So at pH 1, pepsin is going to have a net charge of 0, totally 0. Right? Now what about at pH 2? At pH 2, what will be the charge on pepsin? At pH 2, the amount of OH, the negatively charged ions are more. Negatively charged will bind to the positively charged of the amino acid. You can say that, and overall charge will become negative. You know that a pH above the pi makes the species negatively charged. A pH below the pi makes it positively charged, right? So at pH 2 it will be negatively charged. One important point about ion exchange chromatography is that these chromatographies are used 1 pH below or 1 pH below or 1 pH above the pi. So pi was 1, we are using it at pH 2. 1 pH 1, this is 1 pH above we are using. So it's easy to use, like you don't have to make much changes in the pH concentrations of the columns, right? Now coming to the actual experiment, we had 5 proteins A, B, C, D, E, and among this the C protein we had 5 A, B, C, D, E, and among these this C was pepsin. This is the sample. What is this? This is the sample which we have to separate, right? Now what we have to do, in any chromatography there are two things. One is the stationary phase and second one is the mobile phase, right? Now first of all you take a column. This is the column that I am taking. You take a column, right? In this column, obviously you have to fill up the stationary phase. This is the stationary phase. I am drawing only one date for your explanation. Now this stationary phase should always be charged, and this charge, so that it can bind with the sample which is also charged, right? Sample is negatively charged, negative in charge, right? So obviously this should be positively charged. This should be positively charged. If it is positively charged, the charge on the inner part should be negative, right? So for a anion exchange chromatography, the stationary phase is known as a cation exchanger. The stationary phase is known as a cation exchanger. Is known as an anion exchanger, and this anion exchanger is always positively charged. You can see the positive charge. Now we have to do nothing with these negative charge which are present inside, because when this sample will come on top, it will bind only to these positively charged. It will not bind, actually the word is adsorb. It will adsorb to the positively charged ions which are present on the surface, right? First step of any ion exchange chromatography, prepare the stationary phase. If it is anion exchange chromatography, fill up the anion exchanger that is positively charged inside the glass column, right? Now this was step 1. Step 2, you apply this sample containing A, B, C, D and E, right, onto its surface. What will happen? C will come and it will bind to this positive charge, and A, B, D and E, either they will come over here or they will be eluted out. Clear? A, B, D and E will be eluted out, right? Now third step, actually the thing was we had to separate this C, this pepsin out of this mixture. So what we have to do now? The third step of ion exchange chromatography, of anion exchange chromatography over here, I am drawing a column here. This was your column. You have to apply eluent over here now. You have to apply eluent. Now what should the eluent be? Eluent should be a solution of pH lower in pH lower than that of the sample. pH should be less than the pH of the sample. Now sample pH was sample pH was 2 and Pi is 1, right? Now pH lower than 2 will be pH 1. So eluent should have pH 1, right? And it should have higher ionic strength. The ionic strength should be high. Clear? Suppose this sample was at pH 2 and ionic strength 1 molar. So you will apply the eluent to this solution. I will draw the solution again. This is the bead. You will apply this eluent to this bead at pH 1 now. 1 pH below the pH of the sample, that is at the isoelectric point you will apply. In case of anion exchanger, remember, in case of anion exchanger, you have to apply the eluent 1 pH below the pH of the sample, right? And at a higher ionic strength always. So if this was 1 molar sample, so you have to apply 1.5 molar eluent, whatever the buffer that you are applying. What will happen? This is having higher pH, this is having higher ionic strength. So higher ionic strength means it will bind more strongly to this, right? It is having pH 1. pH 1 means C. C will be separated out, it will come out. Because now C is no more charged, it is neutral, 0 pH is there. So it cannot bind to the positive charges which were present over here. And what will bind to the positive? The positive charges which were present over here, C is not bound to them anymore. So to this positive charges, what will bind? This 1.5 molar sample, because it is having higher ionic strength than this sample which was 1 molar. Clear? So due to pressure created by eluent, in the next step this sample C, which is containing pepsin, will be eluted out. This is your ion exchange chromatography. 3 steps. One was preparation of stationary phase, second is application of sample, and third is application of the eluent, used for separation of charged species. Why we used? Next, if you suspect that in one step this charged species C has not been separated, suppose only 3 C's had been separated and still some pepsin is left, then next eluent you can take up one more eluent at 2 molar, pH 1. The second eluent, this should be the second eluent, and this was the first eluent. This is about your ion exchange chromatography using a anion exchanger. That's all. Okay.